dy upon dx 0 plus 1 by 2, that is 1 by 2. Note it down. Now the next one. First part is tan inverse square root of 1 plus x square plus x. X belongs to real numbers. Put x is equals to cot theta here. 1 plus cot square is cosec square. So we get tan inverse 1 plus cot square plus cot of theta. So we get tan inverse 1 plus cot square is cosec square and square root of that. So we get cosec theta plus cot theta. We can write cosec as 1 upon sine and cot as cos upon sine. Clear? Now take the LCM in the next step. Tan inverse 1 plus cos theta upon sine theta. Now 1 plus cos theta, that is equal to 2 cos square theta by 2. And let this as sine 2 theta, then we get 2 sine theta by 2 cos theta by 2. Cos upon sine is cot. So we get y is equals to tan inverse cot of theta by 2. Tan 90 minus theta is cot theta. Clear? Now x belongs to real numbers. So we get tan inverse tan of this is pi by 2 minus theta by 2. What is the value of theta? Cot inverse x. Now differentiate with respect to x. So what we get? Derivative of cot inverse x. Derivative of pi by 2 0 minus 1 by 2. Cot inverse x is minus 1 upon 1 plus x square. So 1 upon 2 into 1 plus x square. Now the next one is tan inverse, second part, 1 plus x square minus x is here and x belongs to R. So we get this term 1 minus cos theta upon sin theta. Now 1 minus cos is equals to 2 sin square theta by 2 and in the denominator 2 sin theta by 2 cos theta by 2. Sin upon cos, tan. So we get y is equals to tan inverse tan theta by 2. Tan inverse tan theta by 2. So we get x belongs to real number theta by 2. Theta is cot inverse x. Now differentiate with respect to x. Dy upon dx 1 by 2. Derivative of cot inverse x minus 1 upon 1 plus x square. So we get minus 1 upon 2 into 1 plus x square. Note it down. Now the next part, third part is tan inverse 1 plus x square square root minus 1 So we get y is equals to tan inverse 1 plus tan square, that is equals to sec square. So square root of sec square, sec theta. So y is equals to tan inverse sec theta minus 1 upon tan theta. Put the value of sec, 1 upon cos theta minus 1, and tan is sin upon cos. We can write it as tan inverse 1 minus cos theta upon sin theta. By taking LCM, cos theta will get cancelled, so we are left with this term. So we get y is equals to tan inverse 1 minus cos theta is 2 sin square theta by 2. Sin 2 theta is 2 sin theta by 2 cos theta by 2. 1 power of sin will get cancelled. So tan inverse tan theta by 2. So we get y as theta by 2 and theta is tan inverse x. Now differentiate with respect to x. Dy upon dx 1 upon 2, derivative of tan inverse x is 1 upon 1 plus x square. Now fourth one is, here we have plus 1. So we get this when x is tan theta. Instead of negative we have plus here. So what we get? 1 plus cos theta, 2 cos square theta by 2. And in the denominator 2 sin theta by 2 cos theta by 2. 1 cos will get cancelled. Cos upon sin is cot. And tan 90 minus theta is cot theta. So instead of cot theta, we will write it as tan 90 minus theta. So we get y as pi by 2 minus theta by 2, and theta is tan inverse x. Now differentiate with respect to x. Dy upon dx, derivative of pi by 2 is 0. Derivative of tan inverse x is 1 upon 1 plus x square. So we get minus 1 upon 2 into 1 plus x square. Now the next part. Cot inverse square root of square root of 1 plus x square plus x. Put x is equals to cot theta here. So what we get? 1 plus cot square is cosec square. And square root of cosec square, so cosec theta plus cot theta. We get this term. Now we can write cosec as 1 upon sine and cot as cos upon sine. Take the LCM. 1 plus cos upon sine, and 1 plus cos theta is equals to 2 cos square theta by 2. So here we get y is equals to cot inverse 1 plus cos theta is 2 cos square theta by 2, sin 2 theta, 2 sin theta by 2, cos theta by 2. 2 and cos will get cancelled. We get y as cot inverse cot theta by 2. That will be equal to theta by 2, and theta is cot inverse x. Now differentiate with respect to x. Dy upon dx 1 by 2, derivative of cot inverse x, minus 1 upon 1 plus x square. So minus 1 upon 2, 1 plus x square. Now the next part. Sixth part is tan inverse square root of 1 plus sin x plus square root of 1 minus sin x square root of 1 plus sin x minus square root of 1 minus sin x, and the limit is 0 to pi. 1 plus sin x, we can write 1 as sin square x plus cos square x, but here the angle is half, so we will write it as this, and sin 2x, 2 sin x cos x, so it becomes cos x by 2 plus sin x by 2 whole square, a plus b whole square, a square plus b square plus 2ab. So what we get? Cos of x by 2 plus sin of x by 2. Clear? Now 1 minus sin x, sin square x by 2 plus cos square x by 2 minus 2 sin x by 2 cos x by 2. We can write it as cos x by 2 minus sin x by 2 whole square. So we get it as cos x by 2 minus sin x by 2. Now sum of these terms, 1 plus sin x square root plus 1 minus sin x square root. So what we get? This will equals to square root of 1 minus sin x equals to cos x by 2 minus sin x by 2 cos x by 2. This modulus will be positive and negative when 0 is less than x less than pi by 2 and when the limit is pi by 2 to pi. Now the first case will be case 1 is when 0 is less than x less than pi by 2. Then we get 1 plus sin x is cos x by 2 plus sin x by 2 plus this is cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2 minus cos x by 2 minus minus plus here. Is it clear up to here? What we get? Sin will get cancelled, near cos will get cancelled. So tan inverse 2 cos x by 2, 2 sin x by 2. Tan inverse cot of x by 2. We can write cot as tan 90 minus theta. Cot is tan 90 minus theta. So we get y as pi by 2 minus x by 2. Now differentiate with respect to x. We get dy upon dx 0 minus 1 by 2. Clear? Now second case. Case 2 when pi by 2 is less than x less than pi. Then y is equals to tan inverse cos x by 2 plus sin x by 2 minus cos x by 2 minus minus plus sin x by 2 upon cos x by 2 plus sin x by 2 minus minus plus here. So cos x by 2 minus sin x by 2. So what we get now? Y is equals to tan inverse. Here cos will cancel and sin will cancel. 2 sin x by 2 upon 2 cos x by 2. Tan equal to 1 by 2. Note it down. Now the next question. First part is tan inverse a plus x upon 1 minus ax. We know we have one formula, tan inverse a plus tan inverse b, that is equals to tan inverse a plus b upon 1 minus ab. This is a, this is b. A plus b, 1 minus ab. So we can write this as tan inverse a plus tan inverse b. We can write it as this. Now differentiate with respect to x. Tan inverse a is constant term, derivative of that will be 0. Derivative of tan inverse x, 1 upon 1 plus x square. So we get 1 upon 1 plus x square. Second part is tan inverse a cos of x minus b sin x upon b cos of x plus a sin x plus a sin x minus pi by 2 less than x less than pi by 2 and ab tan x is greater than minus 1. So we can write this as, take b cos of x is common. So what we get? A upon b. B is common, cos is common. B cos x is common. So 1 plus a upon b sin upon cos is tan. This will get cancelled. So we have left with tan inverse. Let this as a. A minus b upon 1 plus a into b. So instead of this, we will use this formula. So here negative and here positive. So we can write this as tan inverse a. A is a upon b minus tan inverse b. B is tan of x. Tan inverse tan of x, that is equals to x, because x lies between minus pi by 2 to pi by 2. Now differentiate with respect to x. Tan inverse a upon b is constant, so its derivative is 0 and derivative of x is 1. So we get minus 1. Now next part, tan inverse 3a square x minus x cube a cube minus 3a x square minus 1 upon root 3 less than x upon a less than 1 upon root 3. X upon a is here. So we have to make this term as x upon a. So take a cube common. When we take a cube common, here we have left with 3x upon a, x cube upon a cube. Now, from denominator 1 minus 3 x square upon a square, यही आया हमारे पास. Clear? Now put x upon a as tan theta. So what we get? Tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. This is the formula for tan 3 theta. So we get y as tan inverse tan 3 theta. Now minus 1 upon root 3 x by 6. Here angle is 3. Multiply it by 3. Now these limits are between, for tan, minus pi by 2 to pi by 2. So we will write it as 3 theta. And theta is tan inverse x upon a. Now differentiate it with respect to x. Differentiate with respect to x. dy upon dx, derivative of tan inverse 1 plus x square. X upon a is here. So derivative of x upon a, 1 upon a. So 3 upon a. Take LCM, a square plus x square. So we get 3a upon a square plus